So yesterday we started discussing how to solve systems of equations using a graphing method, meaning that we used a graph to find where these lines intersected. Today we're going to be looking at another method that we can use to solve systems of equations. Before we look at this method, which is called substitution, I want to remind you about some substitution problems that we've seen before. So in this warm-up, for example 1, if I gave you the equation 4x plus y equals 1, and I said that the y value in this problem is equal to 2, what you're going to do is take the number 2 and plug it into the equation instead of y. So you would have 4x plus, and then you would plug in the number 2 equals 1. Now from here we could solve this equation. So what we would do is start by subtracting the 2 on both sides, and we would get 4x equals negative 1, and then we would divide by 4, so we would get x equals negative 1/4. Now, what if we took the same original equation, 4x plus y equals 1, but instead of saying that y equals 2, we would say that y equals 2x. Well, if y is equal to 2x, we're still going to plug that into the original equation instead of the y. All that would change here is that we would have 4x plus, instead of the 2, like we had here in the first problem, we would put parentheses 2x and then equals 1. So we're replacing the y with a 2x, just like we replaced the y with a 2 in the first problem. Now this is still an equation that we would be able to solve. Because 4x and 2x are like terms, we would combine those and we would get 6x equals 1, which we could then solve by dividing by 6, so x equals 1/6. Same idea, we're substituting. We're just this time plugging in a 2x instead of just a 2. Now for problem number 3, we've got the same original equation, and instead of saying y equals 2 or y equals 2x, it says y equals 2x plus 7. So all that we would do is take the 2x plus 7 and plug it in instead of the y. So we would have 4x plus, and instead of the y, we would have 2x plus 7 equals 1. Again, this is an equation we can solve. So, because there's nothing to distribute here, there's just an invisible 1, we would get 4x plus 2x plus 7 if we distribute that 1, and we get 1 on the other side. Now 4x and 2x are like terms, so 6x plus 7 equals 1. Then we would subtract the 7 on both sides, so 6x equals negative 6. And finally, we would divide by 6 on both sides, and we would get x equals negative 1. As you can see, this idea of taking something like a number and plugging it in instead of the variable is something we've been doing for a long time. You'll also notice that in example 1, when we plug in the number 2, there isn't any y left. Like the y goes away. It gets replaced by the number 2. Same thing in example 2. By plugging in the 2x, there isn't a y left. It goes away, it gets replaced with the 2x. And the same thing in example 3. There isn't a y anymore. It gets replaced with the 2x plus 7. This idea of replacing one of the variables is substitution. So any time that we replace or plug in something instead of one of the variables, we call this the substitution method. What we just did here in example 3 is exactly what we're going to practice doing today. So here's the process. Step 1 is to isolate one of the variables. In example 3, which we just did, the y in the second equation was already by itself. But if it wasn't, we would need to take one of these equations and get the y by itself or the x by itself in order to perform our substitution. So isolate one of the variables. Sometimes it might already be done for you. Those are the best problems because they're the easiest ones to start. Then substitute one equation into the other one, which is exactly what we just did in example 3. We got rid of the y in the first equation by plugging in the 2x plus 7. Then you solve for one of those variables, just like we did in example 3 where we got the x value. And then we use that value to solve for the other variable. Just like yesterday, we're going to need an x and a y. It's going to have to be an ordered pair as our final answer. So when you get to the end of the problem, you're going to need to take whatever variable you get the answer for and plug it in to get the actual ordered pair. Finally, we can check our answer. We know how to check our answer because yesterday we practiced taking an ordered pair, plugging it into the original problems, and seeing if that was the right answer in our notes. So, solve the following system using substitution. That is your clue that you're going to want to plug something in to get rid of a variable. So let's take a look. Before you start, you should look at both equations. I notice that in these equations, the y is already isolated in the first equation. The y is by itself. Now in the second equation, the 4x and the y are both together on the left side of the equation, so they're not alone. So what I'm going to do is I'm going to circle this first equation. I'm going to draw an arrow. I'm going to plug in that x minus 4 instead of this y in the second equation. It's going to go away. So let's draw a line, and below there, let's write down what we get when we do that substitution. We're going to keep the 4x, we're going to keep the plus, but instead of the y, we're going to plug in x minus 4. Now you'll notice that the y is gone. There isn't a y left because we plugged in the x minus 4 instead. We replaced it. Now, let's solve. There's an invisible 1 here, so when I distribute that, I get 4x plus x minus 4 equals 1. 4x plus x is like terms, are like terms, so we would have 5x minus 4 equals 1. We would add the 4 on both sides, and we would get 5x equals 5. So finally, we would divide both sides by 5, and we would get x equals 1. Now we've got our x. But in our ordered pair, which is our final answer, we also need the y. So we still need to find the y. What I'm going to do now is I'm going to take this x and I'm going to plug it in to one of the original problems. And it doesn't matter which one. I'm going to use the first one. So if x is 1, I would have y equals, and instead of the x, I would fill in the number 1 minus 4. So all I'm doing is I'm taking this 1 and I'm plugging it into the original problem up here. Now when I do that, I get y equals 1 minus 4, which is negative 3. So I get negative 3 as my y. This right here is my final answer. Now how could I check this answer? How could I be sure that at the end of the problem, I really do have the right answer? So to check my answer, what I would do is take this x and this y and plug them into the first equation, which gives me negative 3 equals 1 minus 4. And 1 minus 4 really does equal negative 3. So the first equation checks out. Now for the second equation, I would have 4. So this is the first equation. Here's the second one. 4 times the x is 1 minus 3 equals 1. 4 times 1 minus 3 is 1, and 1 equals 1. So this checks out. So just like yesterday, we practiced plugging in our ordered pair to both equations to check our answer. Same thing today. We're plugging in our ordered pair, both equations to check our answer, only this time we calculated the ordered pair that we're checking. All right, let's try a few more examples and let's see how this goes. So it says solve the linear system by substituting. When it says the word substituting, that is your clue that you're going to be replacing one of the variables in order to get rid of it. So if I look at these equations, I notice that in the first equation, the y is by itself. So what I'm going to do is I'm going to take that stuff and I'm going to plug it into the second equation instead of the y. Here's what I get. I get x plus 2, and then instead of the y, I'm going to fill in 3x plus 2 equals 11. Now in this equation, I'm going to have to distribute the 2 to both of these terms. So I'm going to have x plus 6x plus 4 equals 11. The x and the 6x are like terms, so I get 7x plus 4 equals 11. Now I'm going to subtract the 4 on both sides, so I get 7x equals 7. And I'm going to divide both sides by 7, so x equals 1. After I have my x, I'm going to take this number and plug it into the original problem, and it doesn't matter which one, in order to find my y. So I'm going to have y equals 3, and then instead of the x, I'm going to plug in the number 1 plus 2. Now 3 plus 2 is 5, so my final answer here is 1, 5. Again, we know how to check our answer, so at the end of this problem, we could always take this x and this y and plug it in to check to see if it really was correct. Let's try example 2. Now in example 2, when I look at the first equation, neither of the variables are by itself. So then I might look at the second equation. In the second equation, this time the x is by itself, which means I'm going to plug this in and replace the x this time instead of the y. So I get y minus 2, and instead of the x, I'm going to plug in negative 3y plus 5 equals negative 3. Now I'm going to distribute the negative 2, and I get y plus 6y minus 10 equals negative 3. Y and 6y are like terms, so 7y minus 10 equals negative 3. I'm going to add the 10 on both sides, and I get 7y equals 7. And finally, I'm going to divide by 7, and I get y equals 1. Now, if I take the number 1 and I plug it into the original problem instead of the y, I'm going to have 1 minus 2x equals negative 3. To solve this, I'm going to subtract the 1 on both sides, and I get negative 2x equals negative 4. Which, when I divide by 2, gives me x equals positive 2. So my final answer would be 2, 1. Okay, let's try a few more examples. Now we're going to get a little bit more complicated. In this example, if I look at the first equation, I notice that both of the variables are together on the left side. And in the second equation, I also notice that both of the variables are together on the left side. So neither of these equations has a variable that's by itself. In the other problems that we've tried already, there's always been either an x or a y that were by themselves. When none of the variables are by itself, first we need to isolate one of them to make that happen. Now we can make some smart choices here. When I isolate my variable, meaning I'm getting it by itself, the first thing I'm going to look for is a variable whose coefficient is 1. And the reason I'm going to look for a coefficient of 1 is because those are going to be the easiest variables to get by themselves. If I look at this problem, the coefficient of the x in the first problem is a 1. That is my clue that I'm going to get the x in the first problem by itself. So to get the x by itself, I would add the 2y on both sides, and I would get x equals 2y minus 6. After that, I just finish up the problem the same way that I've been doing. So if this is what x is equal to, I'm going to plug it into the other equation instead of the x, which means I'm going to have 4 and then parentheses 2y minus 6 instead of the x plus 6y equals 4. I'm going to distribute the 4, so I get 8y minus 24 plus 6y equals 4. The 8y and the 6y are like terms, so 14y minus 24 equals 4. I would add the 24 on both sides, so I get 14y equals 28, and then I would divide by 14 on both sides, so y equals 2. After I know that y equals 2, I'm going to take that number and plug it into either one of the original equations. I always use the first one, and I would get x minus 2 parentheses, instead of the y, I would plug in the 2, equals negative 6. Now 2 times 2 is 4, so I would have x minus 4 equals negative 6, which means I would just add the 4 on both sides, so x equals negative 2. And after I know that x is negative 2, my ordered pair is x comma y, so negative 2 comma 2. Let's try one more of these examples where we need to isolate the variable first. If I look at problem 4, I notice that none of the variables are by themselves. There isn't, like for example in the first equation, the y and the x are together on the same side. In the second equation, the x and the 2y are together on the same side. So the same thing I did in number 3 is I need to isolate a variable before I can start. Now again, I'm going to look for a variable whose coefficient is a 1, and the first one that I see is the y in the first equation. So what I'm going to do is take that first equation, and I'm going to get the y by itself. So I'm going to add x on both sides, which means y equals x minus 3. Now I'm going to take this equation, and I'm going to replace the y with an x minus 3. So I get x plus 2 parentheses x minus 3 equals negative 6. Now it's very important here that I use the other equation when I replace the variable. So let's make a note of that. Must replace in the other equation. So if I rearranged the first equation, I have to plug it in to the second equation, because otherwise you're just plugging it back into itself. Now I'm going to distribute the 2, so x plus 2x minus 6 equals negative 6. X plus 2x would be 3x minus 6 equals negative 6. I would add the 6 on both sides, so 3x equals 0. And then divide by 3 on both sides, so x equals 0. Now this is a place where a lot of students have trouble because they go like, can x be 0? Yes, 0 is a number. That's okay. We can get 0 as our answer. Now I'm going to take that x and plug it into the first equation. You could use either one. I always use the first one, which means I get y minus the x is 0 equals negative 3. Y minus 0 is really just y, so y would be negative 3. So my answer would be 0, negative 3 for this problem. We are going to do lots of practice with this tomorrow and make sure that we are really good at substituting, and then we're even going to learn a third option for solving these types of equations. So I will see you tomorrow to practice this. Thank you so much for watching.